Your company's security model was designed in the 90s. It assumes that if you're inside the network, you're trusted. That assumption has gotten thousands of organizations breached. There's a better way. And by the end of this video, you'll understand exactly how it works. Welcome to AmtocSoft. Today I'm going to give you the complete guide to Zero Trust security in plain English. No jargon, no buzzwords, just the core ideas and exactly why they matter. We'll cover how the old security model worked and why it's broken, what Zero Trust actually means and where the idea came from, the 3 principles every organization needs to follow, a real-world walkthrough showing Zero Trust in action step by step, the biggest mistakes companies make when adopting Zero Trust, how Zero Trust applies to cloud, remote work, and AI agents, and 5 concrete steps you can take today to start your Zero Trust journey. Let's get into it. For decades, network security worked like a medieval castle. You built thick walls around your network, dug a moat called a firewall, and posted a guard at the gate. If someone had the right credentials to get past the drawbridge, they were assumed to be friendly. In practical terms, this meant a corporate firewall. If you were physically in the office, plugged into the Ethernet port, you could access everything. The database, the file server, the admin panel, the HR system, all of it. When remote work appeared, companies extended this model with VPNs. A VPN was just a longer drawbridge. You authenticated once, got tunneled inside the castle walls, and then had the same broad access as if you were sitting at a desk in the office. This model had one fatal flaw, and it was a big one. Once someone got past the gate, they had the keys to the entire kingdom. A single phishing email, a stolen VPN credential, a compromised laptop brought in by a contractor. Any of these gave an attacker complete access to everything inside the network. They could move laterally from system to system, escalating privileges, exfiltrating data, and the perimeter defenses were completely blind to it because the attacker was already inside. Even if the castle and moat model worked in the 90s, the world has fundamentally changed. Today's applications are distributed across Oz, Azure, GCP, and edge nodes around the world. Developers connect from home offices, coffee shops, airports, and co-working spaces on 3 different continents. Your data lives in SaaS applications you don't control. Salesforce, Slack, Google Workspace, GitHub. Microservices talk to other microservices across container boundaries that don't map to any physical location. IoT devices connect from factory floors and hospital rooms. And now, AI agents are making API calls autonomously, without any human in the loop. A single user request might touch a dozen internal APIs, 3 cloud providers, and 2 third-party services before a response is assembled. The concept of an inside and an outside of the network simply doesn't exist anymore. The perimeter dissolved, and any security model built on that perimeter dissolved with it. Companies that still rely on firewalls and VPNs as their primary defense are building castles on quicksand. Zero Trust flips the old model completely on its head. Instead of trusting everyone inside the network, you trust nobody by default. Not the CEO, not the IT admin, not the server in your own data center. Every single request, whether it comes from inside the office or from the other side of the planet, has to prove it should be allowed. Think of it like an airport. Having a boarding pass doesn't mean you can walk into the cockpit or even into the first-class lounge. You get checked at every door. Your ticket is verified, your ID is checked, your bag is scanned. Every step has its own independent verification. Zero Trust works the same way for networks and applications. Every time a user, device, or service tries to access a resource, it has to answer 3 questions. Who are you? What device are you on? Should you have access to this specific thing right now, in this context? If any answer is wrong or even suspicious, access is denied. It doesn't matter if you're the CEO sitting in the office on the company laptop. If the system can't verify your request against all available signals, you don't get in. The name says it all. Zero Trust. Start from zero and make every request earn its access. Zero trust isn't new. The term was coined by Forrester research analyst John Kindervag back in 2010, but it took years for the industry to catch up. Google was one of the first major companies to implement it internally with their Beyond Corp initiative starting in 2014. Google eliminated their corporate VPN entirely. Every employee accesses internal apps through the same internet as everyone else, but every request is verified based on identity and device posture. In 2020, NIST published Special Publication 800-207, which became the definitive framework for zero trust architecture. Then, in 2021, the Biden administration issued Executive Order 14028, mandating that all U.S. federal agencies move to zero trust by 2024. That executive order was the tipping point. It signaled to the entire industry that zero trust wasn't optional anymore. It was the new baseline. Today, zero trust isn't a product you buy. It's an architecture and a mindset that every organization needs to adopt. Zero trust comes down to 3 core principles. Let's go deep on each one. Principle 1, verify explicitly. Every access request must be authenticated and authorized based on all available data points. That means checking the user's identity through strong authentication. It means checking their device health. Is the OS patched? Is endpoint protection running? Is the disk encrypted? It means checking their location, their behavior patterns, the time of day, and the sensitivity of what they're trying to access. No more blanket trust based on network location alone. A request from the office network gets the same scrutiny as a request from a public coffee shop Wi-Fi. Principle 2, use least privilege access. Give people and systems only the minimum access they need to do their specific job at that specific moment, and nothing more. A developer doesn't need access to the billing system. An AI agent analyzing code doesn't need access to customer data. A marketing contractor doesn't need admin rights to the production database. If they don't need it, they don't get it. And access should be just in time. Grant it when needed, revoke it when the task is done. Standing privileges, where someone always has admin access just in case, are one of the biggest security risks in any organization. Principle 3, assume breach. This is the mindset shift that makes zero trust fundamentally different. Design your systems as if an attacker is already inside your network, because statistically, they probably are. The average time to detect a breach is still over 200 days, so segment your network into small zones so a breach in one area physically cannot spread everywhere. Monitor everything continuously. Log every access, every API call, every authentication event. Set up alerts for anomalous behavior. If a developer account that normally accesses 2 repositories suddenly starts pulling data from the customer database at 3 a.m., that should trigger an immediate investigation. Let's walk through zero trust in practice with a concrete example. Say a developer named Sarah wants to push code to a repository on Monday morning. In the old model, Sarah connects to the VPN, authenticates once, and she's inside the network. She can access the code repos, the staging database, the CI/CD pipeline, the production logs, everything. In Zero Trust, here's what actually happens. Step 1. Sarah opens her browser and navigates to the code repository. She authenticates with her identity provider using her username and a hardware security key for multi-factor authentication. Step 2. The system checks Sarah's device posture automatically and silently. Is macOS updated to the latest security patch? Is the company's endpoint detection and response agent running? Is File Vault disk encryption enabled? Is the device registered in the company's device management system? If any of these checks fail, Sarah gets a message telling her to update before she can proceed. Step 3. The system evaluates the request context. Sarah normally accesses this repository from San Francisco between 8 a.m. and 6 p.m. Today she's accessing it from San Francisco at 9:15 a.m. That's consistent with her normal pattern. Green light. Step 4. The authorization engine checks Sarah's role. She's assigned to the backend team, and this repository belongs to the backend team. She has push access to this specific repo. Green light. Step 5. The system issues a short-lived access token that grants Sarah push access to this one repository only, not the whole organization, not even other backend repos, just this one, and that token expires in 1 hour. If Sarah needs to access a different service, the entire process repeats from scratch. Every step is verified. Every access is scoped. Every session is temporary. Nothing is assumed. Let me walk you through the 5 biggest mistakes I see organizations make when adopting Zero Trust. Mistake 1. Treating Zero Trust as a product. Vendors love to slap the Zero Trust label on their products, but Zero Trust is an architecture and a strategy, not a box you buy. No single product makes you Zero Trust. Mistake 2. Only applying it to human users. Most organizations focus on verifying people but completely forget about machine identities. Service accounts, API keys, microservice-to-microservice communication. These need Zero Trust too, and they often have far more access than any individual human. Mistake 3. Keeping standing privileges. If your admin accounts have permanent access to everything, you haven't implemented Zero Trust. Adopt just-in-time access where elevated privileges are granted for a specific task and automatically revoked after. Mistake 4. Ignoring the user experience. If your Zero Trust implementation makes people's jobs significantly harder, they'll find workarounds. Good Zero Trust should be mostly invisible to users through smart risk-based authentication. Mistake 5. Trying to do everything at once. Zero Trust is a journey, not a weekend project. Start with your most critical systems and expand outward. Zero Trust becomes even more critical in cloud-native environments and with the rise of AI agents. In cloud environments, there's literally no physical perimeter. Your services run in containers that might be on any physical machine in any data center. Service mesh technologies like Istio and Linkerd implement Zero Trust between microservices using mutual TLS. Every service proves its identity to every other service with a cryptographic certificate, and every connection is encrypted. API gateways enforce Zero Trust at the application layer, validating tokens, checking scopes, and rate-limiting requests. Now, AI agents add a whole new dimension. When an AI agent makes API calls on behalf of a user, who is the principal? The user who authorized it or the agent itself? Zero Trust says both need verification. The agent needs its own identity, its own scoped credentials, and its own least privilege access policies. If a coding agent needs to read a repository, it should get read-only access to that specific repo with a token that expires in minutes, not hours. The principle is the same whether the request comes from a human at a keyboard or an AI agent running autonomously. To understand why Zero Trust matters, consider how modern breaches actually work. An attacker sends a phishing email to an employee. The employee clicks a link and their credentials are harvested. The attacker logs into the VPN with those stolen credentials. Now they're inside the castle. From there, they discover the network is flat. No segmentation. They move laterally from the employee's workstation to a file server, from the file server to a database server, from the database to the domain controller. Within hours, they have admin access to the entire network. They exfiltrate customer data for weeks before anyone notices. This is not hypothetical. This is how the majority of major breaches happen. The SolarWinds attack, the Colonial Pipeline breach, the Microsoft Exchange hack. All of them exploited the fundamental weakness of perimeter security. Once you're inside, you're trusted. Zero Trust eliminates this attack pattern entirely. Even if an attacker compromises one account, they can't move laterally because every single hop requires independent verification. You don't need to rebuild everything overnight. Here are 5 concrete steps to start your Zero Trust journey today. Step 1. Enable multi-factor authentication everywhere. This is the single biggest security improvement you can make. Hardware keys are best, authenticator apps are good, SMS is better than nothing. Step 2. Audit who has access to what and eliminate standing privileges. Run an access review. You'll be shocked how many people have admin access they haven't used in months. Remove it. Step 3. Segment your network. Don't let a breach in one system cascade to everything else. At minimum, separate your production environment from development and both from corporate IT. Step 4. Replace long-lived API keys and passwords with short-lived tokens. Credentials that expire after an hour force regular re-verification and limit the blast radius if they're compromised. Step 5. Implement continuous monitoring and logging. You can't protect what you can't see. Log every authentication event, every API call, every privilege escalation. Set up alerts for anomalies. Zero Trust adoption happens in stages. Think of it as a maturity model with 4 levels. Level 1, traditional. You have basic perimeter security, passwords, maybe a VPN. Most of your trust decisions are based on network location. Level 2, advanced. You've implemented MFA, you're starting to segment your network, and you've begun inventorying your assets and identities. Level 3, optimal. All access decisions are based on identity and context, not network location. You've eliminated standing privileges. You have continuous monitoring with automated response. Level 4, adaptive. Your zero trust controls are dynamic. Risk scoring adjusts access policies in real time. Machine learning detects anomalies. Security decisions are automated and continuously refined based on new threat intelligence. Most organizations today are between Level 1 and Level 2. The goal is to steadily progress toward Level 3. Level 4 is aspirational for most, but it's where the industry is heading. Five things to remember. The old perimeter model is dead and it's not coming back. Zero trust means verify every request, limit every permission, and assume attackers are already inside. It's not a product you buy, it's an architecture you build over time. Start today with MFA, access audits, and network segmentation. And don't forget machine identities. Service accounts and AI agents need zero trust too. For a deeper technical dive into implementing zero trust with MTLS, SBIFFE, and Service Mesh, check out our blog post Identity is the new perimeter linked in the description below. If this video helped you understand zero trust, hit that subscribe button and leave a comment telling me which topic you want explained next. See you in the next one.